Hi all, today we are going to discuss about genetic algorithm and its operations. Genetic algorithms are stochastic search algorithms which act on a population of possible solutions. Potential solutions are encoded as genes. Genes are nothing but strings of characters from some alphabet. New solutions can be produced by mutating members of the current population and mating two solutions together to form a new solution. Here, better solutions are selected to breed and mutate, and the worse ones are discarded. They are probabilistic search methods. This means that the states which they explore are not determined solely by the properties of the problems. Then genetic algorithms are used in artificial intelligence like other search algorithms. Here are some of the basic terminology in accordance with genetic algorithm. First is population. Population, as we know, is the subset of all solutions to the given problem. Chromosomes. A chromosome is one such solution to the problem. And gene is a one element position of the chromosome. Then allele is the value a gene takes for a particular chromosome. Then genotype and phenotype. Genotype is the population in computation space and phenotype is the population in actual real world solution space. Then fitness function is simply defined as a function which takes the solution as input and produces the suitability of the solution as output. Then genetic operators, they alter the genetic composition of the offspring and these include crossover, mutation, selection, etc. Here is a flowchart of genetic algorithm. This algorithm begins with initializing the population, then comes the fitness evaluation, then followed by selection, crossover and mutation. And the output will be the best one which satisfies all the criteria. Here, as you can see, this algorithm begins by creating a random initial population. And this algorithm then creates a sequence of new populations. At each step, the algorithm uses the individuals in the current generation to create the next generation. To create new population, fitness value of each member is calculated. Then here the selected members are called parents. Then produces children from parents by making random changes to single parent, that is mutation, or by combining the vector entries of a pair of parents, that is crossover. Then the next step is replacing the current population with the children to form the next generation, and the algorithm stops when the termination criteria is met. Here is a pseudocode which represents the genetic algorithm. As we have said now, it first initialize the population and find the fitness evaluation, and while termination criteria is reached, do parent selection, crossover with probability, mutation with probability PM, and decode and fitness calculation, survivor selection, find the best result. Genetic algorithm. Population can also be the subset of solutions in the current generation, and this population is defined as a set of chromosomes. That is, it also can be defined as a set of chromosomes, and the following things to be kept in mind while we are dealing with this population. The first is the diversity of the population should be maintained, and the population size should not be kept very large. This population is usually defined as a 2D array of size of population and chromosome size. Next is the genetic algorithm fitness function. Fitness function is a function which takes a candidate solution to the problem as input and produces as output how fit or how good the solution is with respect to the problem in consideration. This calculation of fitness value is done repeatedly in a genetic algorithm, and therefore it should be sufficiently fast. A slow computation of the fitness value can adversely affect a genetic algorithm and make it exceptionally slow. And here are some of the two characteristics of fitness function. That is, the fitness function should be sufficiently fast to compute and Also, it must quantitatively measure how fit a given solution is or how fit individuals can be produced from the given solution. In some cases, calculating the fitness function directly might not be possible due to the inherent complexities of the problem. In such cases, we do fitness approximation to suit our needs. Now, we are going to see the genetic algorithm parent selection. Parent selection is the process of selecting parents which mate and recombine to create offsprings for the next generation. Here listed are some of the ways by which the parent selection can be done. First is the fitness proportionate selection. Second, tournament or KV tournament selection. Third is the rank selection. And fourth is the random selection. And first is the fitness proportionate selection. Fitness proportionate selection is the most popular way of parent selection. And in this selection method, every individual can become a parent with a probability which is proportional to its fitness. Therefore, this fitness individual have a higher chance of mating and propagating their features to next generation. And next is the tournament or K-way tournament selection. And here we select K individuals from the population at random and select the best out of these to become a parent. That is, it is a random selection. And here the same process is repeated for selecting the next parent. Next is the rank selection. Here, in this method, each individual is ranked according to its fitness. So, in this method, the selection of parents depends upon the rank of each individual. And next is the random selection. Random selection is, as the name implies, the selection of parents is done randomly from an existing population. Genetic algorithm crossover operation. Crossover operator is analogous to reproduction and biological crossover. In this, more than one parent is selected and one or more offsprings are produced using the genetic material of the parents. Here we will discuss some of the most popularly used crossover operators. And first is the one-point crossover. In one-point crossover, a random crossover point is selected and the tails of its two parents are swapped to get new offsprings, as you can see in the diagram here. Here, a random crossover point is selected. Here it is selected as a middle portion and the tails of its two parents are swapped to get the new offsprings. Next is the multi-point crossover. In multi-point crossover, actually this multi-point crossover is a generalization of the one-point crossover wherein alternating segments are swapped to get new offsprings. Next is the uniform crossover. In uniform crossover, we don't divide the chromosome into segments as previous ones, but rather we treat each gene separately. In this, as you can see in the figure, here we treat each gene separately. Then genetic algorithm mutation. Mutation is the part of the genetic algorithm which is related to the exploration of the search space. Mutation is essential to the convergence of the genetic algorithm, while crossover is not essential. And here we are going to see some of the mutation operators. First is bit flip mutation. Here is a diagram shown for bit flip mutation, and in bit flip mutation we select one or more random bits and flip them. Here you can see 1 is flipped to 0. So this is used for binary encoded genetic algorithms. And next is swap mutation. The swap mutation, in this we select two positions on the chromosome at random and we interchange the values. This is common in permutation based encodings. Next mutation operator type is scramble mutation, and In this type of mutation, from the entire chromosome, a subset of genes is chosen and their values are scrambled or shuffled randomly. Next is the inversion mutation. A diagram is shown for inversion mutation. As you can see, here we select a subset of genes and invert the entire string in the subset. Next is the survivor selection. That is, this determines which individuals are to be removed or which are to be kept in the next generation. So here we should also ensure that the fitter individuals are not removed out of the population, while at the same time diversity should be maintained in the population. So there are two methods by which the survivor selection can be done. First is age-based survivor selection. Here is a diagram shown for age-based survivor selection. Here, a certain age are listed, then fitness value is shown, then chromosome and offsprings, and then the output, that is what is the new population. So, this age-based is on the concept that each individual is allowed to continue in the population for a finite generation where it is allowed to reproduce, and after that period it is removed. Here the oldest members are, as you can see in the diagram, the oldest members are P4 and P7. And since the age of P4 is 10 and P7 is 9, so hence the age are 10 and 9 respectively for P4 and P7. We remove that, and the ages of the rest of the members are incremented by 1. Next is the fitness based survivor selection. And here also the fitness value is shown, chromosome, then offsprings and new population is shown. In the fitness based survivor selection method, here the children tend to replace the least fit individuals in the population. Here, for example, here in the figure, the children replace the least fit individuals P1 and P10 of the population, and also since as you can see here, P1 and P9 have the same fitness value 1. So here the decision to remove which individual from the population is arbitrary. Next is the termination condition. The termination condition is important in determining when a genetic algorithm will run or execution will end. So here are 3 conditions or termination conditions: when there has been no improvement in the population for X iterations. Second, when we reach an absolute number of generations. And 3, when the objective function value has reached a certain predefined value. For example, in a genetic algorithm, we keep a counter. Which keep track of the generations for which there has been no improvement in the population. So initially, we set this counter to 0. And if the fitness of any of the offsprings is better, we reset the counter to 0, and the algorithm terminates when the counter reaches a predetermined value. So that's all about the genetic algorithm and its various operations as we have seen. So thank you.